everybody, I'm Chief. I am the primary maintainer of the official octoprint-docker image, and today I want to show you, wow, that light is really doing something. Sorry. Let's see if I can get rid of that. Okay, so today I want to show you mostly how I go about testing the octoprint image, which includes a fresh install every time. So I have a utility that I use to install, and by that I mean a fresh install the operating system. So I have a tool that I use to burn a fresh OS to a fresh card every time. And the testing that I'm doing, I'm referring to like new feature testing. So we have a pipeline that does like a test build and everything, and that's triggered upstream whenever there are changes to some of the dev branches or the releases are released. The operating system that I use, so I test on a Raspberry Pi 4. I've got every single model of the Raspberry Pi 4, so I've tested on everything from a 1 gig to an 8 gig. And I use Ubuntu server, and I've tested 32-bit and 64-bit. The reason I use Ubuntu over, like, say, Raspbian is just ubiquity. I use Ubuntu as my primary operating system, and just makes things basically easier to do, especially when you go about installing Docker with the repos and stuff like that. So what I'm about to show you is I'm going to start off with, I've already burned and flashed my operating system, and basically I've run an apt-get update. If you're familiar with Raspberry Pi or Ubuntu, that's basically just updating the packages on the system, updating the system libraries. Beyond that, so the next steps will be to install Docker. The other things I want to go over today are really how to link your printer, how to link your device, and how to start up the image without your printer powered on, which is essential for some setups. We have a lot of users that don't have the printer powered on persistently, and sometimes the system needs to reboot. And if you hard code into your docker-compose file or whatever other means you're using to set up that USB device, and that USB device isn't there, it'll cause the container to fail to start up. So there is a solution for that, and I wanted to go over that today. I've actually got a docs branch going with there's a little, not really script, but you need to know how to modify your udev config. And I'll show you how to do that. Okay, so my Chrome is acting weird, sorry. Every time I do something, it moves this thing. It won't let me drop the window, so I'm just trying to move things around. Give me 1 second. I think that worked. Okay, so what you see here is basically, like I said, this is this new system that I logged into. It is right now I'm running ARMHF, so this is a 32-bit, and this is, I named the machine, the host name is Octotest, and I'm running the kernel 5.4 Linux kernel. And I believe that this is 20.04.02. Oops. I'm trying to think of the pulling up the Docker stuff right now. Whoops. There we go. So 2.04.1. So this is a focal, and we're running 32-bit ARM-HF. So the first thing that we'll do, I've pulled up the Docker instructions for installing on Ubuntu. We are going to install their GPG key. Okay, with that done, I'm going to, this basically is going to create a whoops. This is going to create a package list file. So if we were to go into we'll now see a docker.list in there. So we'll do an apt update, and this should add the Docker packages to our available package registries. And now I'm going to install Docker. One quick note, so my install script does some things like group management for me. So one thing you want to make sure with your operating system is that you're a member of, especially the plug dev group. There's no Docker group yet. We'll be taking care of that. You'll especially want to make sure you're part of the plug dev group. GPIO, you may or may not need that. So that is a group where, depending on how your particular operating system is handling GPIO devices, whether they're using a character library or the sysfs library, which if you're on Raspbian, the GPIO group isn't going to be a big thing for you. But if you're on a newer distro, the sysfs library, which traditionally controlled like GPIO output and output state, has been deprecated for a while, and so Ubuntu actually uses the new one, and it'll group your GPIO devices using this new GPIO group instead of like before. I think you just needed to be part of the root group. Okay, so we're going to install Docker here. Anyway, some OctoPrint plugins and stuff use the Raspberry Pi GPIO. If you're not using a Raspberry Pi or any GPIO, don't even need to worry about it. Did I forget to run update? No, I ran update. Like I said, this is a fresh OS, so hey Jim. By the way, if anyone's watching, feel free to say hello in the chat. I am looking at it from time to time. So while this is going on, what I will show you is, by the way, this is the tool that I use to burn new operating systems easily. It's just a utility that helps basically take the same OS and flash it. Takes a few minutes, gives you a fresh OS. You're ready to go with a lot of the groups and stuff you need set up. Anyway, so one of the things that I'm going to show today is how to do udev rules for dynamic USB devices. And by that I mean your container will start independently of whether or not your printer is attached, or this should also work for, or it will also work for other devices, whether they're USB devices or other devices. It uses a feature called C groups, which is actually the core of what Docker is built on. And instead of passing a particular device to the container, you'll pass a C group. And then what you'll do is within your, so there's a library on Linux called udev, and what happens is it's your device controller. So whenever you plug in USB devices or Bluetooth devices or anything, any type of peripheral, it runs an event to basically, load the driver for that device, add it to the right groups, give it the right permissions, etc. Assign it to the part of the device tree on the system. So one of the things that you can do is run an arbitrary command whenever a device is recognized. And you can also recognize a particular device. Each device has properties like the manufacturer ID, the vendor ID, the product ID, what subsystems it uses, things like that. And so what we'll be able to do is write a script that basically looks for the running Docker container and runs a command within that Docker container to refresh devices whenever you plug in a printer. And that script is actually pretty simple. It is right here. So whenever you add or change a device that matches what is essentially a 3D printer, you're going to run this command. So this is a syntax that's specific to udev. That's what these C stands for character device, %M stands for major bus, and %M stands for minor. So if you were to run, I'll do it over here. So here you can see all the different devices I have plugged in. So for example, one of my Oculus Rift sensors is on bus 2, device 3. So what this would be is it would be a C character group for major is, actually this is device character group, so it would be a C group. So this will show that there's a better command for just getting the particular pieces that you need. But basically each type of device has a different C group. What it comes down to is the 3D printers typically have one of two C groups. And I believe it's 188 and 208. I'm looking to see if I've documented that part yet. But we'll go over how you can configure this for your system. Let's see, we're about 60% through this. There we go. So there's our major and minor. You're seeing, well, this is ls block is just block devices, so storage drives. In a minute, I'll be plugging in 3D printer motherboard. So to test this out, I don't really need a full 3D printer. You really just need the motherboard, which I had sitting here. I thought. There it is. Okay, so this is a SKR 1.4 motherboard. It has Marlin 2 burned onto it, and I've got a Raspberry Pi sitting right here that I'll plug it into. Probably should have run the upgrade before I did the stream start, but almost done here. Oh, this is fun. So what this is doing is generating a kernel boot image, which is something that's done after every time you run an upgrade. And this is a step you don't want to interrupt because it can cause you problems with booting. So a little bit about the Raspberry Pi that I have set up for testing here. So it's using a rpi-camera. I believe it's a rpi-cam V2 with the ribbon cable. depending on your operating system, there's a kernel flag that you'll have to set to make sure to start video drivers for that, so that you get access to the video device. And that's something else that I'll show you how to look for. That can also cause problems when you're trying to do linking to the container. Okay, so next step is to try to install Docker. Still getting this. Let's check to make sure we did the RMHF. This is concerning. I'm going to cheat. Basically what I did is I just told my package manager to use the package repo for Bionic instead of Focal. I guess I could have tried to look to see if it was a nightly or test for ARMHF. But Docker's always had issues with the package repos, which is ironic because it's a system that runs on Linux, and Ubuntu is like the most popular operating system there is. So it's, don't get me started. Okay, so last thing we're going to do, I'm going to run sudo user mod -a docker and then my username. So what this should do is when I reboot, it will show me as part of the Docker groups. So I need to log out to do that. So I'm just actually going to log out. Did I do sudo with that before? Yes, I did. That's weird. Maybe I just didn't see it. Oh, it's there. Okay, I just didn't see it before. Okay, so now we got Docker installed. We're running Docker version, whatever the latest is, 20.10.6. One last thing I'm going to, okay, Git's already installed, good. Okay, so now where we're at is we have a system that should be ready for the most part to install octoprint-docker. So one thing that I'm going to look at real quick is dev. So what I'm looking for actually is video. So we've got dev video 0. We can see here that its group is major group is 81, minor group is 0. And notice how there is no ACM device or anything like that here. So at this time, I'm going to take my test board and I'm going to make sure that it's set to USB power. And I'm going to plug it in to my Raspberry Pi. But what I want to show you real quick is a command to monitor udev. So you'll see kind of what fires when we do this. So we'll run sudo udev adm monitor. Okay, so watch what happens when I plug this in. Exciting. That should have registered. Unless there's no rule for it, that could be why. Okay, so let's look at dev real quick. Is my board not on? I may have a problem with my board. I may have to pause this stream because I may have my test board may be fried. I think I have another board I can test real quick with. Okay, I have a new board, and let's make sure that this one is set to USB power. Okay, this one's not getting power either, so it's a problem with the Raspberry Pi, maybe? This stuff always happens when I do a live stream, never when I'm just tinkering. I'm gonna try rebooting the device. Well, I could explain a few things. Okay, I do see power on my main board here. Now that I've physically turned the power off and power back onto the Raspberry Pi. Let's see if it's back up. Okay. So we do not have, oh, that is strange. We don't have dev video 0. So this does happen sometimes. So what probably happened, so remember earlier how I said it was creating a new like boot image. So you have like what's called your init RAM system that creates this what's called a VM Linux image, and that contains all of your like boot parameters into like a the core of the kernel that it boots. So normally you have to start with a particular boot option to enable the Raspberry Pi camera. So I either tweaked it so it's not plugged in, or, which it seems like it's firmly attached, that kernel image that it created did not carry that over. So what we're going to do, oops. So that X video equals 1 is the, what's really needed for the Raspberry Pi camera. something real quick. This probably will not work, but yeah. I'm going to reboot again. Looks like it did not properly load the user config edition for that. That's what my guess is, so we'll just see. There we go. Okay, so we got video 0 there. So it's important that I kind of ran across that because I think a lot of users are going to see that. It's important also that you see that whatever group that this is, you make sure that your user, so this is, the first list is the owner, the second one is the group, and this specifies basically how permissions are added. So what this is saying is the owner has read-write and the group has read-write, and there's nothing for other. If this were to say root, and you were to look at groups, and obviously I'm not in the root group, that mean that there could be permissions issues. So even if I'm doing like a privileged container, there could be issues if the user inside the container doesn't get the right group mappings and stuff like that. Okay, so we've got video there, and let's take a look at, we'll do TTY real quick. And we've got no, so we do have, so there's ACM0 and AMA0. So I'm going to unplug this, and the one that we're looking at specifically is ACM0. You'll see that it's there. So if I unplug this, notice that there's nothing there. And I plug this back in, I've got power, it's there. So this is what I wanted to show you earlier. So I'm going to run udev monitor. Oh. And I'm going to unplug this board. And notice how it fired off basically a bunch of events. And you see, like, you know, kernel commands being issued to remove the device and unbind it and everything. So watch what happens when I plug it back in. So there it just bound this device and added it to the device tree. Okay, and this part right here is important because it's telling it, you know, what bus to use and things like that. So what you're looking at here is what bus it's connected to. So I believe this OpenMoco Inc. is what we're looking at for our device. The first one is the vendor ID and the second one is the product ID. So there is a way to get this, and that is to do sudo udev adm info. Just doing this will give you the device path that you need to pass. And so what I tend to do is I'll do dev bus USB, and then I know that this is 001 and the device is 005. And so this will tell you the major number. So this is the major C group number and the minor C group number. This is the kernel subsystem ID vendor. Basically, these are all properties of the USB device. We'll use this in a little bit to create a container startup config that can allow you to dynamically start and stop the container without having the printer powered on and plugged in. But first I'm going to do a regular container startup. So let me check to see if there's any comments yet. Did I grab power only? Oh, Jim, I think you were referring to back when I was having some issues. No. I'm not sure exactly. I think the Raspberry Pi was stuck in a boot loop earlier. Or I had rebooted it, but not hardware rebooted it. Or physically rebooted it. So everything's working now. Okay. So there are a couple ways to get started. The easiest way, I'm just going to make an octoprint directory. and I'm going to cd into that octoprint directory, and then I'm going to type vim. I'm going to say set numbers, or set number, so that we can see line numbers. And then what I'm going to do is I'm going to come to this octoprint-docker, and I'm going to grab this docker-compose. I'm just going to grab these lines, and I'll hit set paste so that I can paste, and then I'll type the I key and then Control-Shift-V to paste this in. There is, if you don't want to use Vim, there's another way. Basically, you could run a curl command to download this. I'm not going to go over all the different ways you could get like a file onto this machine. If you're using the headless version of the Ubuntu server, I'm assuming you already can kind of know that. And if you're not using the headless version, then you can just use a file editor, text editor, whatever, save a file. Download it using the GitHub configs, or just type out and create your own file. Okay, so the first thing that I'm going to do, so we're going to use the octoprint image. I am going to enable the mjpeg streamer. Now this 1, 2, 3, 4. This config file is white space specific, so we need to make sure that this is 4 spaces and not a tab. And then I'm going to enable that. So again, I'm going to make sure that this is 6 spaces. I'm going to go back and check to make sure the rest of my configs that I want are set up. So I want to make sure camera dev default is dev video 0. So I am going to use dev video 0, and I'm going to use delete that. So that is 1, 2, 3, 4. Okay, so this is my setup that I'm going to start with. Okay, what did I do? I'm going to do unless stop, and ports are going to be 8080. And devices dev tty cm0, and I'm going to map that to dev tty acm0. So this is what it's saying is the host device and the guest device, or the map it into the container at that particular path. And then the last thing I'm going to do is volumes. Dang it. We'll say octoprint, and that goes there. And there's one last thing I need to do, and that is to define my volume. So I'm not going to use host mounted files. I'm going to use a Docker container volume, and that's all that's required to make that happen. So now I'm going to save that file. You know what? I probably still need to install docker-compose. This is always a pain because I think I have to use pip, and I probably don't have that installed or set up, I should say. Okay. Oh yeah. Thanks, Jim. My fingers are all over the place today. So I need to do the video device as well. So this will be dev video 0, and we'll map that to dev video 0 in the container. Okay. I don't know if this will work, but we'll see. Okay, so I've got Docker Compose installed. What I want to do is verify that my Docker Compose file is legit file, and there's an easy way to do that. So we can just say docker compose config. Figures. Let's see. So this is probably going to fail the same way. I hate Python. Finally. Okay, so now that we've fixed the Python installation on this machine, I'm going to run docker-compose config, which if it spits out your config, you're good to go. If you have a problem with your config, it will tell you where your problem is. Let's say you have a syntax error. I'll add an extraneous white space there. We'll run config again, and I think it's automatically correcting it actually. So some things it can automatically fix. Let's say you missed something there. Whoop. There you go. Tells you that there's invalid stuff. So the first thing to do is just make sure that you've got a valid thing. Okay. So what I'm going to do now is I'm going to start the container, but I'm going to start it with the log stream running. So I'm going to say docker compose up, and usually I'd give it like a -d or something like that, which would make it start in the background. For now, I'm just going to do this, which will it's going to download it because I don't have any of the images on my system, and then it's going to start the container. Now remember, I gave it the camera device and the printer device, which right now is dev tty acm 0. This is a good time to mention that there are two different primary variants of the Docker image for Octoprint. There's the main image, and then there's the minimal image. So the main image has a process supervisor. It runs a couple different services. So it runs an HA proxy that kind of front loads all the different services behind the URLs. It runs obviously Octoprint, and then it runs the JPEG streamer service. There's also a octoprint minimal image, and the minimal image is, there's no process supervisor. It's literally just Octoprint. There's no camera support, anything like that, and that's intended to be used if you want to use different containers on top of or in conjunction with the Octoprint container. So say you want to provide your own MJPEG streamer container, you want to provide your own HA proxy container or other traffic container to do traffic direction, stuff like that. The minimal image is going to be right for you. There's also quite a bit of difference in size. So this started up. So really what I'm looking for is just to make sure that there are no errors. Everything looks good, and at this point I should be able to go to my octotest.local should be the URL. Of course, Google thinks I'm searching, so I need to use HTTP. I'll show you a quick trick. Actually, I'm not going to bother with that right now. So I know that the IP for this is 8.3. So for now, we'll just use the IP address. So you can see that immediately you saw that we've got this traffic come in here. So this is what you should get. So we've got our first container running. I'm not going to restore from backup. I'm just going to create a test user. So I'll say chief, and I'll put in a password. Hunter 2. And we'll do next. I usually disable this stuff. I'll show you in a little bit how you can do pre-configuration for all this stuff. I do that a lot for when I'm doing actual testing so that I can iterate really quickly on changes. I'll enable that. I'll do next. You can set this stuff up if you want. Like I said, I'll show you later how to do that. Server commands, this is important. If this doesn't show up, you want to make sure to put that in there. So there is no way to restart the actual container from within the container. That can only be done outside the container. But because there's a process supervisor in the main OctoPrint image, there is a way to restart the OctoPrint server without restarting the container entirely. And that is by using the command CLI for the process supervisor, which is S6. So this is just saying restart the S6 service OctoPrint. And that should be it. So finish. I am going to go in here real quick and look at webcam. So I'm going to run a test here, and you can see this is me. Hi. That's my window. This is my workshop, and I don't know why this is all red. Could be any one of a number of reasons. I'm not gonna look at it right now. It could be power, could be camera lens, could be a whole bunch of stuff. Anyway, so that's the stream test. Snapshot URL is good. Testing, all this stuff should show up. So I'm going to save that. And if we go here, let's go back. And there we have our stream. So if you just want to access the stream, this is how you do it. Hi. Okay. So there are some questions. There is a question. I'm working with GitHub contributor by the name of Paraphraser, and I think he is one of the main either creator or maintainers of the IoT stack, and he's having some issues with that URL, and so I think that comes down to some permission stuff. Earlier on I mentioned make sure that your groups are set up right. The other thing is like port numbers. We'll take a look at, there's a couple different things that can factor into it, but this is the setup that I use, and depending on if you're using a USB camera, your groups could be different. A whole bunch of different things can happen there. Anyways, so let's see, where are we at? So let's see if I can connect with auto. So auto connection state is operational. Everything's good to go. So this is the basic health check state that I have. It stands up, it can connect. You can see here in the logs, it's dev tty acm 0. The serial detection performed auto detection. Try and port dev tty acm 0, tried different baud rates, handshake, everything worked. So from there, there's also some questions around, I've seen a lot of people say, you got to map dev tty acm 0 to dev tty usb 0 inside the container. problems can arise there at times because those two things are part of different C groups. And I'll go into that in a little bit when I show you how to do dynamic device, basically how to decouple the container and the device from being plugged in and starting with each other. But for now, all I've got is there's no real printer attached to this. I do have drivers on board so that we could test like the TMC driver status, stuff like that. These are TMC 2208s, so they're trinamic drivers. But obviously I do have the end stops jumpered here so that I can so that they don't cause errors on startup. Otherwise, I could cause errors with Marlin startup. Eventually, I'll put like button toggles on those so I can just physically like hit physical push buttons. So this is all part of my testing rig. I'll show you some other time. I've got like a whole bunch of, it's just a aluminum like 80-20 extension. So it's got like 3 rows and it's got steppers slotted in, and it just a whole bunch of stuff. Anyways, okay, so at that point, this is where when I edit, I'm probably going to do a basic cut because that's basic setup, install, everything good to go. So from here, next things that you look at, the considerations are installing plugins, backups and restores. Those are major features that I test. The removal of a device and reconnection. So right now, if I were to remove this device, we'll lose connection to it. And if I reconnect, there's issues within the container, right? So, well, maybe not. That used to fail. Sometimes what can happen though on your host when you reconnect this device, depending on if you've got like multiple printers on your machine or multiple USB devices, you could get different bus assignment. You could get a different place in the device tree, and that could screw up your container. So there is a way to fix that. So for here, there's one other thing I wanted to show. So I'm going to shut this container down real quick. And what I'm going to do is say docker compose up-d and docker compose logs, I think it's -f. So this is basically the same thing I had before, except for if I stop out of here, it's not going to shut down the container. You can see it logged in the user, and I'm good to go. And if I exit this, see the container is still up. So I'll reconnect. I can run docker compose ps, and you'll see that OctoPrint is running. Okay. I want to show how you can use the OctoPrint CLI to change some configs. So say like I logged out and couldn't figure out my password. So I think I'm admin and my password is test. Nothing. OctoPrint has a CLI. And what you can do is you can use the docker-compose exec command to issue commands via the CLI. Where is my And that's actually one of the things that I do. If you look at my Docker file, so this is my test Docker file, so you can see it builds on OctoPrint, and then I actually do, I create a Docker secret, so I'll create a password, and then I do a Docker build, and I run this octoprint command, give it a baster, user add admin password, and do everything. But I can just as easily say docker-compose exec octoprint and I'll say we'll just do bin bash. So I'm now in the container. I can say which octoprint. This actually might not work because the command, we'll just say octoprint version. And there we go. So we'll say octoprint baster let's say chief 2. Okay, there we go. So now, I thought it should have prompted me for the password. Let's take a look at the docs. Okay, so it would be octoprint baster octoprint user add admin password, we'll say test, and then the name of the user is bootcc3. Make sure I got everything there. There we go. So I'm going to log in here to my OctoPrint container with Chief3 and test. I may need to reload the container. And there we go. I logged in with Chief3. So this is just a demonstration that you can use the CLI through the docker-compose exec command. So the way that I did that, again, I just ran docker-compose exec octoprint, and then I ran bin bash just so I could drop into a CLI. Oh, duh. And then I ran the octoprint command. I gave it a base dir of octoprint. I do believe there was a feature request that I think we had discussed of being able to put octoprint base dir as a supported environment variable, so all the CLI commands would automatically ingest that. I think that has made it. I'm not sure. But to see the... What did I do? Docker. Oh, duh. I'm not in the octoprint directory. So let's just make sure that it's running. It is up. So now we'll run this. And I don't believe this has history. Oh, it may actually. Yes, it does. Okay. So we can now take a look at users. We can say user lists. We've got 3 users. We can change passwords even. So I could say help. And we'll say user password help to get the... So user password -- password. We'll say new password, and the username that we'll give it is Chief3. And there we go. So now my password is changed. So if I come in here, I'm going to log out. Again, I may have to restart the container. I don't know for sure. This will just be new password. Yeah. Okay, so now I'll log in with Chief3 and new password. There we go. And now we're logged in. You can also use this to change permissions of users, remove users. There are a whole bunch of config options that you can use via the CLI, but this is really good if you haven't logged in a while and you want to, like, you forgot your password or you even forgot your users. You can use this to either, remind yourself what was the username that I used, or hey, I just want to set a new password. The reason it's important, if we look at the OctoPrint container, what actually happens is there is a config file. I'll show you. So we'll go back into this container and we'll do ls-al, and then we're going to cd into octoprint here. And we've got our config.yml. So what happens is when you create a user with a password, it actually hashes that password. So the password is never stored in clear text. And so you'll see if we look at, we've got our salt and user file. Let's see, go down here. I believe there's actually a users. .yml, yeah, users.yml. And this is what it looks like. So the reason you can't just like type a password into a config file and preload that into a container is because it gets salted and hashed. And there's really no way to do that other than through the OctoPrint CLI or through the OctoPrint UI, creating a user, which runs through the same algorithm. That's why my test utility, what it does is during the build, so I use Docker, what's called Docker secrets. So I create a secret for with the Docker engine, store like a password that I use to test. And during the build of the container, after the Docker service has been built, after the original config file has been moved in, it runs an OctoPrint CLI command to create a new user with a particular password. And that means that I can automatically bring up a new OctoPrint instance. And I've got all those other configurations that you typically see in the welcome screen, like setup. Do you want to disable plugin blacklisting? Do you want to do all that kind of stuff? These things already set. And so the last piece of that you need is user creation. And so by doing this, it's essentially a way to stand up a new OctoPrint service from scratch without a like a prompt screen ahead of time. You can set all those options, and this allows you to just really quickly like migrate Docker instances. Assuming that you're using Docker volumes, you could just use move Docker volumes. If you're doing host maps back for these config files, you could move over these config files that are created. But we also support, as of I believe V2 of the OctoPrint image. So the OctoPrint image versions are different than the OctoPrint versions themselves. So we're on like image version 3 something. The best way to do it right now is just backup restore. So create a backup, stand up your container on another system, and then just import. And that will go through all the rest of the screen with all the options that you already had. So it'll bundle all this up for you. Okay, so let's see. I actually need to take a break, so I may do another stream a little bit later to show you the dynamic USB device stuff. Basically, to give you a primer, there is a Docker Compose flag that is called cgroup device rules. So I would modify my Docker Compose to look like this. So I would say instead of devices, or in addition to devices, I could say cgroup device rules, and basically what you do here is you select the type of device. The USB device that we use for printers is a character device. I don't know what group it's in. Let's find out. I think it's 188, but I don't know. We'd say 188, and then we'd say read write. So give the permission, right? Let's take a look. So is 166, my bad. So it could look something like that. And basically it's saying anything in that, any character device in cgroup 166, any minor device, give it read-write permissions. Let's double check to make sure that's the right syntax. Device cgroup rules. That's why. Or at least one of the reasons why. We'll find out once I fix that. Okay, there we go. So what will happen then is that allows me to so I can delete this entirely. And I would still have access to that device from within the container. Now, at the moment, that's not going to give the full disconnect, unconnect thing. So there's a second piece of that comes with udev, and that's where I have in my rules for dynamic, my branch here that I'll be moving in. You've got to basically reach inside the container when the device is removed and remove dev octoprint. So basically what this does is I'm setting it up as a unique kind of device, and call it, instead of like mapping it at dev tty-acm0, I map it to dev/octoprinter, and that means basically whether it's using USB, whether your specific printer maps to USB 0 or tty-acm0, it should be able to map to dev octoprinter. It uses this command to basically make device node for that device inside the container. So basically what will happen is whenever you plug in a physical device on your host, that matches these udev rules, it'll reach into your octoprint container and physically refresh the devices inside your container. So basically what that means is normally when you give Docker Compose a specific device, like we were before, if that device is not present when you start the container, you'll have container failures. So let's try that real quick. 1, 2, 3, 4, 5, 6. I know I said I wasn't going to do this and now I'm doing this, but for now I'm going to comment this out. Okay, sudo, or just Docker Compose stop. Okay, So that stopped. I'm unplugged my printer, and now I'm going to do docker-compose start, and you'll see that there's no device. So I'll do this instead. So now I'm going to remove that device. And instead I'll say docker-compose start. Did I not update that? It might be stored in the service, so I need to do there we go. So now there's no printer. And I started it. So notice my printer is not attached, but I was able to start my container, and I can log in to OctoPrint. So the next part of the video, the next time I do a video, what I'll show you is basically how to use udev and a few commands to find out information about what your printer looks like to your Raspberry Pi or whatever machine you've got it on, to set up a udev rule that automatically refreshes the device listing inside of your container whenever a device is turned on and off. So what I just showed you was how to start a container without a printer attached, which is pretty important because you can do that without Docker. And so really that's the next step to being able to kind of utilize Docker. OctoPrint's not really the best candidate for Docker containers, but one of the major reasons was the interaction with physical hardware, and that causes problems like we just saw, where there are container issues whenever the hardware state isn't exactly what Docker expects it to be. So today we solved how to start it, and maybe later today, tomorrow, sometime I will show you really how to get to that next step with this udev rule. If you want, you can start on your own. This is almost fully fledged, or it is fully fledged. It's just tested on my single machine. I had issues getting device mapping to work and that's because of precedence of udev rules. So it would still assign it as dev tty-acm0, even though I have, there's actually another command in here where I need to add it to a group and symlink it. Anyway, I'll go into more of that later. If you want to look up how to do udev rules and mapping, the important part is this run command. If you take this run command, see how it's add, change, and remove? These commands are what interact with your OctoPrint container to update your device listing. All right, that's it for now. I'll see you next time.